Welcome to a brand new series, Build Your Own DApp, or BYOD. The main idea of this series is to actually build a DApp on KALP Studio, on the KALP DLT, all from scratch. We're going to be creating this smart contract as well as the front end that connects to that smart contract, right? And we're going to be deploying it using KALP Studio on the KALP DLT blockchain. The API gateway, integration, all of that. So from 0 to 100, all in one video. We're going to be linking all of the documentation in the video itself. We're going to be building a certification DApp. And if you guys have heard about Soulbound Tokens, that's what we're going to be using today. So what exactly are Soulbound Tokens, right? Are essentially NFTs. You can think of them as NFTs. They are non-transferable. Let's take an example. A student goes to a college. Once you complete college, you get awarded with like a degree. This degree is actually bound to you. That's exactly where these Soulbound tokens happen, right? So once we mint these tokens for a particular user or for a particular wallet address, tokens are not transferable anymore. Academic degrees are one such use case. Hackathon certifications, right? Google has a lot of certifications, and these certifications in the professional world usually kind of show that you know your stuff, right? You take exam, these are bound to you, and these sometimes expire in like 2 or 3 years. So we can actually modify our smart contract to accommodate those as well. So that's what we're actually building. So what tech stack are we using? So we're going to be using Golang for the smart contract creation, KALP Studio to deploy those smart contracts and to interact with those smart contracts as well. And for our front end, to create an entire DApp, we're going to be using Next.js in this video. Maybe we'll add a bit of Tailwind CSS, but in this video I'll just be showing you how to actually set up your DApp and also interact with the actual blockchain itself, right? With the smart contracts which are actually deployed on that blockchain. Let's actually look at a short demo. Did it not? This is already deployed on our dev server. So we have a few fields over here. The username, let me just give my name. A user email, we're going to be using this email. And the organization, let's just use KALP Studio for that. And the date of issue will be today, right? And we need a wallet address now. Now, I'm going to kind of skip ahead and go to KALP Studio. I already have my wallet here, so I'm going to copy that wallet address and paste it over here. And once we click on Issue Certification, it'll say, yeah, it's minting the certificate, and congratulations, your certificate was successfully minted. Now, if I go to all SBTs, you can see the token IDs of all of the tokens. We can verify our certificate as well. So if we put in our wallet address over here, we'll see that we have like this certificate over here, which was issued to us just now. And it was awarded today. So this is kind of like what we're trying to build here. We want to issue certificates. This app is actually called Certify. All of the documentation for all of this will be linked in the video description. And join the Discord, be part of the community. If you have any questions, if you want to build cool dApps, if you have questions, if you want to grow and use the KALP DLT, learn more about blockchain, the Discord app is very good for that. Make sure to follow us. So let's kind of go into like the setup of this video. So as I said, we'll need two things. We're going to be using Golang to write our smart contracts, and we're going to be using Node.js, or rather the framework Next.js, to actually build our DApp. So let's start with Go. On KALP Studio, one very important note. When you go to the website that actually makes you install Golang, like if I just search install Golang, and I go to the go.dev website, it will automatically make you download version 1.24. We don't want to do that. KALP Studio actually supports up to version 1.20. So you make sure that your Golang version is actually 1.20. Now, in order to do that, we'll go to all releases page of the Go website, and we'll kind of scroll down until we see 1.20, right? I'm going to be using 1.20.6. So go over here, and based on your operating system and architecture, download the necessary file and then install it from here, right? And don't worry, if you guys ever get lost doing this, right? We do have documentation for this, right? So this document will be linked in the description of this video. And this will kind of go over how you can actually use the KALP SDK. So it also says here, you can download Golang from here, and it will also say that your Go version should be 1.20. So that's essentially how you install Golang. Once you actually successfully install Golang, let me just open up my terminal. Yeah, once my terminal is up, in order to check your Go version, what you do is you go to Go version, and you just type that, and it should say Go 1.20. And you're ready to go. You can start creating a smart contract. Now, in this video, we're going to be using Next.js, so we need Node.js for that. So in order to install Node.js, we just go install Node. A couple of ways to do this. The best way, in my opinion, is to use NVM, the Node version manager, because that lets you kind of manage all of the different versions of Go, like in one system, right? Instead of just installing Node, one version of Node on your system, right? So use any of these guides to install NVM, and we want to kind of install Node version 22. So if we go here and we do, first of all, this is a Mac, so I'll have to do source nvm.sh in order to start up NVM, and we go node-v, and this will tell you which version of Node you're actually using. So I'm over here, I'm using Node version 22.9.0. This will come in handy later when we actually start building the actual dApp itself. That's pretty much it for the installation part. So let's kind of move forward and go to actually building our smart contract. But how do we do that exactly? Again, if we look at the documentation over here for KALP SDK, this will give you like a step-by-step guide on how to use the KALP SDK and how to create a first smart contract. Let me just do that here. So I'll go over to my terminal and I'll create a new folder, right? Let me just change directory to desktop. I created a folder called dapps. I'm going to make a directory called certification and cd into that, and contracts. And cd into contracts. So I'm going to be doing all my coding within the certification folder that I've created. And under contracts, I'm going to be initializing my Go project. So what we want to do is you want to do Go mod init, and I'm just going to call this Soul for Soulbound Tokens, right? So once we do that and we do an ls, we can see that there is actually a Go mod, which was go.mod file, which was actually created. Now, let's just go over and open up our code editor. So I'm going to be using Visual Studio Code over here. And once this comes online, you'll see that Go mod, module Soul, and then Go 1.20. Great. So now what you want to do is you want to kind of install your KALP SDK right before you actually get started. The way you do that is we'll go over to the documentation. We'll copy one of this line, which is go get, and then your KALP SDK. Let's just copy that and go over here. Let's open up my terminal within VS Code itself. And I'm going to paste this in. As you guys can see, there is a -u over here, which is like a universal install, right? So it'll install it for your entire system. We don't want to do that. We just want to install KALP SDK for this project. So once I click enter, go get, and then that URL, it will modify your go.mod file, right? And now you can see that there's like a bunch of stuff over here. And this installed our KALP SDK public. Now, let's actually kind of talk about, before we actually continue forward, let's kind of talk about what our smart contract is going to do, like the structure behind our smart contract. Our smart contract, as I said, is like a normal NFT. In Golang, the way we define stuff is using structs. We want to create our own data structures within that. So two of the most important things within the Soulbound token is the SBT metadata struct and the Soulbound token struct. Now, the SBT metadata struct is what holds the description, the name, the organization, the file link rather, that goes into that NFT. And then the Soulbound token struct is like a unique token ID, and it has a bunch of metadata in it as well. We're going to be creating 4 main functions within the smart contract. So we're going to have mint SBT, we're going to have query SBT, we're going to have transfer SBT, and we're going to have get all token IDs. Transfer SBT is basically just a method to like block transfers, right? For the Soulbound token itself. It's not, we're not going to be technically using it. We're going to be just minting it for a user. The main functions that we're going to be using is the mint SBT and the query SBT to get the details of the token itself. So let's kind of start coding. So over here on our VS Code, what you're going to do is we're going to create like a new file, right? I'm just going to call this soul.go, and this is going to be package main. So this is going to be my main Go file, and within this, I'm going to first of all define a struct for the smart contract itself. Now, once you, the way you actually deploy smart contracts is actually by creating like an instance of the smart contract, right? And then you deploy it. So before we create our main function, let's just define this, right? So type, and this is going to be a normal struct, right? And it's going to contain only one thing. It's going to contain the actual contract class for the KALP SDK, right? So KALP SDK dot contract. So once we have this, we let's start by creating our actual main function, right? So our main function is just going to create like a new chain code instance, and once that is done, it will check for some errors in deployment and make that chain code available for all of the rest of the functions, right? So let's create our main, func main. It's not going to have any input parameters, so we have chain code error. And if you guys don't have like a very good grasp on Golang itself, right? There are a bunch of tutorials online, right? And also we have also done a bunch of webinars, right? So on our YouTube channel, which will be in the description, check out our other videos. We do have a bunch of tutorials for Go as well there. So, and we basically try to start from scratch, teaching you Go and then going into smart contracts. So do check that out. So now what we're going to do is we're going to call that KALP SDK instance, right? KALP SDK dot new chain code. That's what we want. And we want to use our struct that we created for the smart contract, right? So, and smart contract, and like so. So in Golang, before compiling, if there's like any variables created, you need to actually kind of use them, right? Otherwise, it'll throw an error whenever you're compiling the actual smart contract, right? And Golang is a compiled language, right? So let's just handle these errors first, right? So if error is not equal to nil, then what we want to do is we want to do fmt dot printf. Now once I used fmt, it'll automatically import that package, so you don't have to worry about like importing it, especially on like a VS Code or anything. Error creating chain code. And then this is just normal error handling stuff. So I'm going to give it the value, right? It'll actually throw out the error itself, right? And now what we want to do is we want to use this chain code to actually start that chain code, right? This particular chain code instance. So chain code dot start, right? And error not equal to nil. fmt dot printf and then we're going to do the same thing, right? Just doing a little bit of error handling over here. Great, now our main function is done. Now let's start by creating a initialize function. So the way KALP Studio actually handles its smart contracts is that by default, all of the smart contracts that are deployed on the KALP DLT are upgradable. Now, what that means is that we have to actually kind of use like an initialize function to initialize that smart contract with certain variables before we actually start using that smart contract, right? And the initialize function is usually called just once in its lifetime. So I'm going to be creating like an initialize function over here. The way you kind of actually see whether a function within Golang is a function that interacts with the chain code itself is by having this receiver. So if any of these functions have the chain code, the smart contract instance receiver function, then it will essentially be interacting with the actual state of the blockchain. So that's one very good way to kind of figure out what the functions are within the smart contract, that is. So for initialize, we need a couple of things, right? We need the SDK, which is just the context interface for the transactions, right? So this is going to be KALP SDK, KALP SDK dot context. Transaction context interface, and let's just give this a description, which is a string. So, and what this function will return is an error. So this is like a general structure for like a function within Golang, right? So you have any receiver functions over here, the function name, and then your parameters, right? And also you define the return type of that function. So what you're going to be doing here is, let's just start with return null. Because this function kind of expects an error to be returned, right? So an error can be either something like this, which is something throwing an error, or it can be nil. So I'm just going to return nil to kind of show that this function actually executed properly. So let's start by checking to see if this function is actually, this smart contract is actually initialized first, right? So as I said, a smart contract would be initialized only once in its lifetime. So we don't want people to keep calling the initialize function. So what we do is initialized is equal to SDK dot get state. So what SDK.get state does is it checks the blockchain ledger to kind of see whether a particular key value pair exists or not, right? And we're going to be giving it the key to find out whether that value exists. And we're going to be using the key initialized for this. And some error handling. If error not equal to null, or rather nil in this case, then return fmt.error. F failed to check. Contract initialization, and we're going to be doing %v. Oh, this is going to be a comma over here. And now we want to kind of see if this initialized variable exists or not, right? And by default, this is going to give us like a byte array, which if you're like storing strings in it, you'll have to kind of convert it later, or any number value, you have to convert it later. But if this exists, that means that this smart contract has already been initialized before, right? So if initialized not equal to nil, then what we do is return fmt.errorf. And the reason we're returning errorf is because this function actually returns an error, right? So that's why we're actually returning an error if there's something wrong. Already initialized. Great. So now what we're going to do is we're actually going to be using the SBT metadata, right, to kind of store our description that we are getting over here from the input parameters. So let's actually create a new struct over here. Type SBT metadata struct, and I'm just going to put a description over here, right? Or rather, I should be using like a capital letter over here. Description is going to be string, and this is going to be like a JSON. Description. Actually, let's actually kind of build our metadata a little bit more, right? So although it only has like a description right now, let's actually give it a name as well. String, and then I'm just going to copy this part over here, and this is going to be name omit empty. So if it is like empty, it will just omit it, right? Going to give it a description, a name, an organization, and a date of issue. So every token that we actually mint will have this metadata attached to it, essentially. Organization, string. So let me just kind of move this over here and this over here. And actually, you know what? I'm just going to copy this and organization, and I'm going to create another using for date of issue, right? Great. So our SBT metadata struct is ready now, right? Close the brackets over here, right? So, and now what we're going to be doing is let's go back to our initialize function, and let's actually create like the metadata for the description, right? So SBT metadata is equal to SBT metadata, right? Description is description. And we're going to be marshalling the struct, right? So since this is like a, in node terms, it's like an object, right? What we want to do is before actually saving it onto the blockchain itself, right, into the state of the blockchain, or at the state of the smart contract, we're going to be actually converting this into like a string and then putting it that way, right? So metadata JSON error, like so. JSON.marshal SBT metadata. I don't need these extra brackets over here. And again, let's do a little bit of error handling. So I'm just going to copy this, and I'm going to fill to Marshall. So once we have this metadata JSON, what we're going to be doing is we want to kind of save this onto the state of the blockchain, right? So we kind of looked at the SDK.getState function, right, to get like a key value pair from the state of the smart contract. Now what we want to do is we want to actually put this state for initialized. Or rather, first we're going to be putting the state for the metadata, and then we're going to be putting the state for the initialized, right? So let's store the metadata over here. So error SDK, SDK dot put state without KYC. So we're going to be using this function called put state without KYC to actually update the state of the smart contract itself. And going to be using the key metadata over here, and then the metadata JSON, right? And as you can see, once you marshal the actual object over here, right, that we created, it will actually return us like a byte array, which is what we use to kind of store data onto the blockchain, right? And then let's just do another error handling, right? Fail to store, right? Fail to store, that should be good enough. And then we're going to do like another put state for the actual initialized key value pair, right? So let's put state without KYC, and then here I'm just going to be using this key over here, initialized. Fail to store the metadata yet. Fail to store, not metadata. This will be or rather okay, so we're using this key over here. Now what we're going to do is, what we are actually storing not the metadata itself, we're going to be storing like a Boolean value over here. So let me just typecast this. Or rather a string Boolean, right? Because you just need some value over here. So this is our initialize function. Now let's kind of move forward to like the actual mint function for this, right? So up till now, what you've kind of seen is that we can get state from the actual smart contract state, right? And we can also put states, right? So get state is basically we are getting information or the data from the blockchain, and putting state is actually we're kind of changing the state of the blockchain. So we are kind of updating the values which are stored on the blockchain, right? For this particular smart contract. Next, what we're going to do is we're going to actually mint our tokens, right? So let's create a function called mint SBT. So now this mint SBT function will have like a few parameters, right? One parameter that we definitely need is this SDK contract interface. So that will be there for like almost every function which actually interacts with the blockchain itself. But for this token, we are storing like the address, or rather the user address, right? The name of the user, the organization, and date of issue. So before actually we continue forward building this function, let's actually kind of create the struct for the Soulbound token itself, right? So let me just create another struct over here. And I'm just going to copy this for now. We need to have like an owner. We need a token ID. And we need metadata. So let me just JSON owner. We don't need omit empty, right, for this. So let me just build a struct, and then I'll kind of explain what's happening over here. So we have our Soulbound token struct. As we know, any token has like an owner for that token, right? And this owner is going to be like the wallet address for the person we're actually minting this token to, right? We're going to be having like a token ID attached to this token, so that we can uniquely identify our token, right? So this is essentially what will make our token unique. And then we have the metadata, right, which is just going to be the rest of the information, which is going to be the rest of the information, which is going to be like the date of issue, when was it, if it is expiring, if the expiry date, etc., etc. So let's kind of go back and see our mint SBT function, right? So let's, for the input parameters, let's have like the address of the user. So as you guys saw, the struct above that we had created, it had like a metadata attached to it, right? So that's where like most of this stuff is going to go, like the name, the organization, the date of issue, etc., etc. If the certificate is expiring, we can also add like a date of expiry to that token as well. And this is going to return an error. So now what we're going to do is we want to kind of generate like a new token ID for our tokens, right? So we're going to be using UUID in here, right? Because Golang kind of supports that. So let's do this. Token ID. UUID dot new dot string, like so. Okay, before we actually continue, since this is actually returning an error, let me just return nil over here to kind of get all of this good old highlighting over here. Did it not import this properly? Okay, one issue that I saw was that it does not know what UUID is. So let's just do this, right? Let me just expand on this. Instead of go get this, I'm going to be getting go get UUID. And now we can see that this is working fine, right? Yeah, this package UUID. So it creates a new string for this UUID. Great. So whenever you get stuck, like why are things not working, usually VS Code will highlight and it'll tell you, this is the issue. Like it imported like the UUID from the Google package, but it said that, it can't really find it. So kind of be careful on like what you're trying to do. If it doesn't work, look at the errors that are thrown. It's pretty easy to debug, right? Now, moving forward, we have generated a new UUID. So let's actually start minting our token, right? So I'm going to write out the entire function, and then I'm going to kind of explain what's happening.
How's it going, guys?
Should I get it? All right, so I'm finished like creating the mint SBT function, right? So let's go over it like from the beginning. So at the very beginning, we're creating like our token ID using the UUID package, right? And then we kind of try to get like the metadata for the smart contract. And then a bunch of error handling. And then what we're doing is we're trying to like get the description that we got from initializing the function, right? The initializing the smart contract. So we're creating like a new variable for the SBT metadata, right? What we're doing is we are mapping. So once we actually get the SBT metadata, what we're trying to do is we're trying to like create like a key for the owner to actually own this token, right? So we do that by using the sdk.createCompositeKey, right? So we're going to be using a prefix, owner mapping prefix. I've created like two prefixes over here, the owner mapping prefix and the SBT prefix. So the owner mapping prefix will be mapped from the user's wallet address to a particular token ID. And then the SBT prefix will be from the token ID to the actual data which is stored within that token. That's where createCompositeKey comes in, right? So we use a prefix and then we use something else that kind of defines what this key will be mapped to, right? And we're going to be using this key with conjunction to like get state and put state without KYC, right? So once we get like the mapping key, we check to see if like this particular user already has like a soulbound token attached to him. Because in our smart contract, what we're trying to do is once we mint like a token for our user, another token can't be minted, right? So this is like a one-off certificate that once the user has a certificate, he can't mint any more certificates for himself. So that's why we're checking the existing token ID over here. If that already exists, then we're throwing an error, right? And then what we do is like we try to update like the metadata, right? So we created like a variable over here for the SBT metadata. So we put in the name, the organization, the date of issue. Let me just see if I'm not missing anything. Yeah, I'm not missing anything. So once we like update that metadata itself, we want to convert it into like a byte array, right? So that we can kind of store it. So that's what this updated metadata JSON is. And then we actually create our token itself. So the SBT Soulbound token, it has an address, it has a token ID, and it has the metadata attached to it. So this metadata will essentially be linked over here to the token itself. So, and hence this token will be linked to like the user wallet address, and it will also have like a unique token ID. So we create that object and then we marshal it again to convert it into like a JSON format. And then what we do is that we're going to be creating like another composite key. And now this composite key is basically for like a mapping from for the address and the token ID, right? And this composite key will basically have all of the information for the user and whatever token that he owns, right? So if you want to search from like either the wallet address or the token ID, you can do that, and then it'll give you like the SBT JSON, right? Or the Soulbound token metadata for that. Cool. So once we create that composite key, we're going to be storing our data. So we're going to be updating the state of the chain code or using put state without KYC. And once we do that, we just need to update one more thing, which is the mapping key. So for the token, what we're going to be putting is the mapping key and then the token ID over here. Once we update like the owner mapping for this, that's pretty much it. We have successfully minted like a soulbound token for our user. Once that is finished, our main function has been completed. I'm just going to be creating like one more function, and then I'm going to be pasting the rest of the other functions, right? So the next function that we're going to be looking at is going to be like the get function for the token. So we're going to want to get the token information for either like a token ID or the user, a wallet address, right? I hope that this is not that really confusing. The only confusing part could be that this create composite key, what it's doing, right? So it's basically using like a prefix and attaching like a whatever variable to that prefix to create like a key that you can use to like put state, put data into the blockchain, right? And that's essentially what we're doing. Either put state or like get. Later we're going to be using like the get state as well for that. So that's that. Let me just double check one thing. This mapping key. This mapping key was from here, right? Yeah. So this mapping key essentially was us creating like a key for the address. So this links the address to the token ID itself. So yeah, this is all correct. Next function that we're going to look at is we want to query all of the soulbound tokens, or rather get a particular soulbound token. So in order to like get the data for that soulbound token, what we're going to be doing is we're going to be using the token ID and also the wallet address, right? Because that's what we saved it as for this SBT.json. We want this information back. Let me just create this function, and then I'm going to kind of explain what's happening over here, right? Smart contract, query SBT. All right. So this is like a very quick query SBT function, right? So what this kind of does is it takes the owner, which is the address of the user, and the token ID, and it gives back the token variables essentially. What it's doing is, again, as above, when we were putting the actual state of the token, we were creating like a composite key using the owner and the token ID. We are creating the composite key again, but instead of putting the state, we're now getting the state using that composite key, right? So we get the token data, and then what we do is we kind of unmarshal that token data, and we put it into this variable SBT, right? And then we just return that, simple stuff, right? One other function, what we are going to kind of create is get SBT by owner. So as we know that these tokens are like owner bound, so I'm not going to like create this entire function from scratch. I'll just copy paste this from something that was already created. And I'm just going to kind of explain what's happening here. So what this does is that when we were kind of minting our token, right, we had this restriction over here that a particular owner can't have more than one SBT. Now, where was that exactly? It was existing token ID over here. If it was not null, then the owner already has an SBT, and then we throw an error, right? So that kind of means that whenever like an SBT is minted, the user can only have one of it. So we can actually kind of use that to get like the actual token information from the owner by just putting in the owner's wallet address. So what we kind of do here is like we create like a composite key again, but using only like the owner mapping prefix. So as you know, that the owner mapping prefix was linking the owner's wallet address to the token ID. So we use that, where are we? Query, yeah, to get the mapping key, which in turn we get the token ID, right? Now once we have the token ID, we can do the same thing that we did above here, right? Which was create the SBT key using the owner and the token ID, and then same difference from what we did in the previous function. So the extra part was just getting the token ID from the actual owner mapping that we did, right? And these will be like the main functions. There are like a few other functions, two more functions. There's a transfer function, which will essentially block all transfers. Just one second. Which I'm just going to copy and paste over here. So this function basically just blocks all transfers, right? So it has like a from, a to, a token ID. So if anybody tries to do this, it'll say that Soulbound tokens are not transferable, right? It'll just return this error. The next function that we're creating is the get all token IDs function to kind of get like all of the token IDs that were actually kind of created. So I'm just going to put that here as well. So what this does is that it just runs through and sees what all token IDs are there that were actually minted, and it will get all of that information back to you. The way we do this is by using now a new function over here, which is get state by partial composite key, right? So when using a composite key, we looked at earlier that we were creating a composite key, but for creating a composite key, we needed to have like the exact variables that were within that composite key, right? So that's why we couldn't do create composite key and then with just the owner wallet address, right? We needed this token ID over here. But over here, what we're doing is we're creating like a partial composite key, right? and we're using like the token, the owner mapping prefix. So we're getting all of the tokens that were minted, and we're getting all of the token IDs for that, right? And that's where all this iterator comes in. So this will like return you like an iterator over which you can loop and get all of the token IDs that you want, right? So this defer iterator close. So once you like open like an iterator, you need to close it. Once you have that iterator object, right? What we're doing here is we actually kind of creating like an ID, the token IDs array that we're kind of going to return. So this function basically just returns all of the token IDs that were ever generated. So for iterator.hasNext, this is just basically a Boolean, right? Whether there is a next for this iterator, right? And then iterator.next response, this will just get the value, the query result for that iterator, for that particular value of that iterator. And then we're going to take the token ID from the response.value. And we're going to append it to the token IDs. Very simple stuff. The token IDs, again, array of strings or other UUIDs. And over here, we're just doing another error handling thing, which is checking to see if the token IDs, if none of them exists, then it'll just return, oh, there's no SBTs found. And then it just returns the token IDs. Great. So once we actually complete our smart contract, and this is basically all of the functions that are within the smart contract. And this is like a medium, small to medium sized smart contract, right? The main function, let's kind of go over it again, are initialize, which sets the description for the metadata. And it makes sure that initialize can't be called again. Mint SBT, which generates like a UUID, a random UUID for that token, and it mints a token for a given address, name, organization, and date of issue. Then followed by the query SBT, which was getting the token ID, which was minted, getting all of that information from providing the owner and the token ID. But since we are like generating the token ID, instead of using query SBT directly, because we won't know what the generated token ID would be, we are using get SBT by owner. So here we're just using the mapping key to get the token ID and then doing the same thing that we did above. And then transfer SBT is just there so that we block all transfers for this smart contract. And then we get the get all token IDs, which gives us like a list, or rather an array of all the token IDs which are ever generated. Let's kind of do one more thing over here, right? So once we have successfully like created our smart contract, the next step is to actually compile it and deploy it. So in order to compile this smart contract, what we do is go mod tidy, go mod vendor. Go mod vendor, what it does is it creates like this vendor file, right, which contains all of the packages that were imported from the go.mod file, right? And then we do go build. And once we create this go build, if there's any errors within that file, this will actually throw those errors. But since it didn't say anything, it's very similar to like C or any other compile language, where a success is basically it says nothing to you, right? So this was a success. Now what we're going to do is we're going to deploy this onto our KALP DLT blockchain. So the way we do this is we go over to KALP Studio. And if you guys haven't signed up for KALP Studio, do that. Create your own account. It's actually pretty simple. If I can just show where to go. So you go to accounts.kalp.studio/sign up to create like a KALP Studio account, right? And once you sign up, you can then log in to KALP Studio, right? And once you log in, you'll kind of see something very similar to this. And you can click the link in the description to create your own KALP Studio account, or you just go to the link which you see above here. What you want to do is you want to go to console.kalp.studio, right, which will actually direct you directly to the console, right, the KALP Studio console. And we're going to be using two main apps within KALP Studio here. One is the KALP Instant Deployer and the API Gateway. So let's just use the KALP Instant Deployer first. So what you want to do is you will want to create your own wallet. So since I already have a wallet over here, I'm just going to attach that and go to deploy new SBT. I'm just going to call this SBT. And then continue, and this will ask you to drag and drop your file over here, right? And it says the supported formats are tar.gz, tar.xz, and zip. But what we have done here is we have all of these files over here. So what we are going to do now is we're going to open up our file explorer, right? Yeah, we're going to go into our where our contracts are, and we are going to highlight all of them and compress, and then zip them up into a zip file. And once this is zipped, we can rename it into, let's say, sbt.zip. So once we have this, we can now upload this directly on to KALP Studio, right? So I'm just going to use here, drag and drop, and continue. Now, the deployment process will take a couple of minutes. Just be a little bit patient. So once this actually successfully uploads our smart contract, it will actually tell us via email and over here whether it was a success or not. Now, I've already deployed a version of this smart contract before, so I'm just going to use that to kind of demonstrate what the functions actually do, right? So we have our Certify app over here. At first, whenever this is a success, you'll want to generate your endpoints. And once we do that, we will come over here and then we can interact with the blockchain directly. So I'm just going to open up Postman and kind of test out all of these different functions. So I have all of these different functions within KALP Studio. So I'm going to click on Initialize first. I'm going to create a new post request. I'm going to paste in this address over here. And then you go to check params, get your API key, and put in your API key over here. And for the body, check params, and we want raw, JSON, and this, right? So if you guys have a little bit of trouble following what I just did, there's a very good video on how to actually use KALP Studio, the KALP Instant Deployer, the API Gateway on our channel. So kindly check that out. So once I hit initialize, it should come back as a success, right? Hey, this transaction was successful. It'll give you a bunch of information over here saying where it was deployed, the transaction hash, etc., etc. All right, cool. So once this was initialized, let's try to mint a token. So what I'm going to do is I'm going to duplicate this tab. I'm going to paste that in, and I'm going to mint our token. So as you saw that we have like an address, a name, organization, date of issue. And this was consistent with what we had actually created over here, right? So if we kind of roll this down and we go into like the mint SBT over here. So we had like the address, name, organization, date of issue, right? So all of these variables input variables will be available to you right here. And let me just put in like an address over here. Let me disconnect. Let me just use like a different wallet address for this. So I'm going to be using that. And that's my address, name, Rohan, organization, KALP Studio. Date of issue was, what's the date today? 28-02-2025. And once we hit the mint, once we send this request, it'll actually mint like a token for us. And it came back as a successful response. Now, how do we check to see if this was actually minted to us, right? For that, we actually use the get SBT by owner function that we created, right? And remember, there's get SBT by owner function. What that does is it takes in the user's wallet address, gets the token ID that was generated for it, and it returns you all of the data that is there for the token that we minted. Pasted that. And once we call this, this is going to query the blockchain, get data from the blockchain, and we need to provide like an owner address over here. So I used this wallet address. So once it gets that data, we will see that, hey, we have that owner, we have that token ID, which was a UUID which was generated. And we have all of the metadata as well, right? So we have the description, the name, the organization, date of issue. If you want to add, let's say, an image URL or a URI, as they say, to this variable, to this token, you can do that as well, right? Any data that you think that will help bind your SBT to something useful, you can add into the metadata, right? And that's the smart contract. We just interacted with it on using Postman. So what we've done up till now is we have created our smart contract for our SBT token from scratch. And we had a couple of different functions. We deployed our smart contract using KALP Studio on the KALP DLT blockchain, and using Postman and the API gateway, we have created endpoints to interact with our smart contract. So this is our backend part done. Now, what we want to do is we want to actually create like a front end, right? We want to show our tokens, our SBT tokens. Let's just create like a front end to mint our tokens as well. So if you come over to this GitHub repository, the BYOD templates, and under the certify branch, let's just clone this very quickly. So I'm over here. This is my dApps certification. So over here, we have our contracts folder. What you want to do is we want to clone this template for our front end. So let's just do that. So git clone -b, and -b is just a flag for the branch that we want to clone. And we want to specifically clone the certify branch. Certify, and we want to paste the URL. for this GitHub repository. And if we look over here, we'll see that we have our BYOD templates repository cloned successfully. Now, let me just go into my Finder, dApps, certification, and let me just rename this to Certify. And we want to cd into Certify. And if we do an ls over here, you'll see a bunch of files already there. So let's open this in VS Code. So this is what it will look like in VS Code. If you look over here under package.json, you'll see that, oh, we are using Next.js for our frontend. So we'll just be using that. So let's very quickly do one thing. Let me open up my terminal over here, and let me just do an npm I to install all of the dependencies that are required for this. So as soon as this is done, and the node version that we're using is 22.9. In order to start up our front end in development mode, what we do is we do npm run dev. Under scripts, you'll see there's a dev, next dev. So if you run this command, npm run dev, it'll start a local instance of the front end, right? And we're using Next 15, by the way, in order to do this. So if we go into our localhost 3000 over here, you'll see that there's a bunch of already pre-made front-end elements over here. And this is the Certify app. It is giving us an error right now, and we'll fix that error. So first of all, what we want to do is we want to go back into KALP Studio, and we want to go into the smart contract that we deployed for this during this tutorial. Now, the first thing that we want to do is let's copy over the API key. So I copied over my API key. And if you look over here, sample.env, there is 2 env variables over here. So I'm just going to copy this and paste this over here. And I'm going to rename this to just .env. You can do .env.local, whatever, but there's only, I'm just going to have just the .env over here. Now, the next public API key. This first environment variable, I'm going to put in my environment variable API key over here from the API auth key. I'm going to copy that and paste it over here. And now we need a public wallet as well. So we will actually go over here and select the wallet that we used to deploy our smart contract. So if we go into params, we'll see our wallet address over here as well. And or what we can do is we can go to connect wallet and select our that we used, right? And we can copy the address for that wallet from here as well. So I'm going to do that, and I'm going to paste that over here. Cool. So these are just a few things that we need in order to actually call these APIs, as you saw in the Postman example. So we have our API key over here. We have our wallet over here. All right, cool. We need 2 more things for this to work. So if we go into hooks and we go into user sbt.txt, ESX. Over here, you'll find that there is a KALP Studio input field over here with the base URL, the fixed wallet, and the contract ID. Now, the base URL, you don't have to change it. This is just the API gateway URL with the API-gate gateway.api.kalp.studio up until KALP. Our fixed wallet will be our wallet address that we copied from over here. And we're just going to paste that in. Now, our contract ID is our contract address that we got once we deployed our smart contract. And we can find our smart contract address over here. So we click on this button and we paste it over here. Cool. And we save this. Now, what we've essentially done is that we have taken all of our variables from deploying our smart contract and put it into our frontend over here, right? Into our template. And in order to use this template, we need only these few things. Now, let's go back to our browser and open up our Certify app. And if we reload, it is still giving us an error, which is a hydration error, which should be fine. That should be fine. If we go into get started and we view all SBT, it will give us an error because we haven't actually created any tokens on this yet. So we go into our issue/verify SBT. So let's just kind of see how this this is working. We have two paths over here. We can verify a certificate or we can issue a certificate. So let's issue a certificate to ourselves. So let's go on get started over here. And we have already created like a form over here for creating our certificate. And we have also created like a template for our certificate as well, which is pretty cool. All of this is done for you. So all you have to do is input the necessary details and it will mint out an SBT token for you, which is pretty cool. So let's just use my name. So I put in my name over here. For the user email, I'm just going to use any random throwaway email for now. And the date of issue, let's just set it for today. And we need a wallet address. So this will be the user's wallet address. So in order to do that, let's go back into KALP Studio. And let's just grab another wallet. So this was our issuer or our minter. So I'm just going to copy this wallet address over here. And I'm going to paste this over here. Cool. Now, once we have our wallet address over here, let's click on issue certificate. And once it's successfully done, you'll see that, certification has been minted successfully. Your achievement is now permanently recorded on the blockchain. Pretty cool. So let's go back over here and let's verify our certificate. And don't worry, we'll go over all of this, what it's doing and whatnot behind the scenes and kind of look at the code, how it is actually calling all of these APIs in just a minute. Once we verify that it's actually working. So we have our own wallet address over here. So we paste in our wallet address. And once we click on verify, we have our certificate. So certificate of appreciation, my name, awarded today. So yeah, you can verify that your token was actually minted. And if we go into all SBT, you'll see that our token ID was also created. So if you remember, we used the UUID package on Golang to generate like a token ID for all of these tokens. So it was generated over here. Cool. Now let's kind of go into the code of this and see what's actually happening over here. So if we go into our app folder, and you'll see the landing page, which is just a landing page, all of that HTML and CSS for that, built on the KALP Studio test blockchain. So this is our landing page over here. Secure blockchain, all of this stuff. So if you want to kind of go over and see what's exactly happening with the CSS for this, you're more than welcome to kind of explore and change it up to your standards. So what we want to do is we actually want to go into our Mint SBT page. So this is our Mint SBT page. So the way you kind of navigate through Next.js is our URL followed by our Mint SBT or whatever the folder name was, right? So that was mint-sbt, and under app, you'll see a mint-sbt folder, and that's how Next does its routing. Under app folder, you can create a folder within which there's a page.tsx, and that will be just your route. So let's kind of look at the code for this as well. So you'll see a bunch of interfaces over here, right? For the form data, you will see the mint results, you'll see notification data. We're not kind of concerned with the notification right now. And you'll also see the form input props. So this is our main form that we're using. So we have our input, we have our label, we have our icon, and we have our input field for this, right? There's also a wallet display, there's a mint button. But what we are mostly concerned with is the actual minting part of the token. So if we scroll down, we'll see the mint SBT function, which is a functional component of React. So this mint SBT is getting its functionality from this use SBT API that we have created. And what it does is that it creates a state for the form data, and it takes in the recipient address, right, which is the recipient's wallet address, the recipient's username, the user email, the organization, which is just set to KALP Studio, and the date of issue. And once it gets all of this data, it sets the loading state to false, and it sets it creates also another use state for the results. So and then there's a bunch of form handling, form validation, that within this form, if we go here, if any of these fields do not occur or are not there, then it will return an error. Now, the main functionality that we want to see is the handle mint functionality. So it will first of all take the validate form,
check to see if all of the fields are properly filled out. And then it'll set loading to true. It'll set the result from the actual API call. And then it will then try to call that function, which is our mint SBT function. So let's actually go into the mint SBT functionality itself. And we're using await mint SBT as API response. So this is where we're actually minting our tokens. So from the form data, we are taking the recipient wallet address, the username, the organization, and then the date of issue. So let's kind of go into this mint SBT. So you'll see that once we go into the mint SBT API, this is under hooks folder, right? Which is separate from the app folder. So we'll have a bunch of functionality over here. So all of the smart contract functionality that we use to interact with the smart contract itself that we actually got from the API gateway is already set over here. So we have our initialize, which just takes a description. And if we go back into our KALP Studio over here, you'll see that our initialize does indeed just use a description string. Now, mainly is the mint SBT, which has the recipient address, the username, the organization, and then the date of issue. It will return like a make request for our mint SBT. So let's actually go into this make request. What does this make request do? So this is the actual function which is sending the fetch request to call the API gateway routes that were generated. So we have our endpoint, we have our args, and we have an isQuery boolean, and which is by default set to false. So in order to mint something, this isQuery would be set to true, or rather, this would be set to false for our mint. So this basically sets whether it is a query or an invoke type function. So if we kind of look at our routes that were generated over here, you'll see all of them start with Gateway API, KALP Studio, V1 contract KALP, and the mint starts with, let me just open up over here. The mint goes into an invoke. And if it is not a mint, let's say we are getting functions from the blockchain. Then, for example, get all token IDs over here. This will be a query type. So that's essentially what that's doing. It is setting whether it's query or invoke. And then it's setting the URL path, which is the API config.base URL. And this is where we put our base URL slash invoke or query. So for mint, it would be invoke, and our contract ID, which is our contract address. And then followed by whichever endpoint it was. And our endpoint would just be the function name for that particular function that we're trying to call. So in this case, it would be mint SBT. This mint SBT. And once it sets all of this up, it gets the API key from the process.env. And that's why we put our API key in our env file, this API key, so that we can use it once we actually call the functions that were generated on the API gateway itself. And if it doesn't find it, it'll throw an error, which it should. And then it is doing a fetch request on this URL. The method would be post. So this would be a post request. Under headers, it will put your API key that you put in our env, and content type application JSON, right? This basically says that the body for this is going to be of JSON format. Cool. And then for the body, what it is doing is that it's doing a JSON or stringify on the args, the arguments. So let's kind of look at this create request config function. Now this create request config, all it does is if we go back here and go into check params, we see a bunch of stuff over here, right? So we have our network, our blockchain, our wallet address, and then our arguments. So it's just setting all of this up. So we have our network, blockchain, wallet address, and it is putting in our arguments over here as well. So once that is done, let's just go back. Over here. And once it does that, it awaits that response for the call to the API gateway. And if the response is okay, which means that it's a 200 level response from the API, it skips this. If it is not, then it says, oh, there's an error processing the particular API response. And once it gets that data, once the response comes back okay, it kind of takes the JSON, takes the response, and gets the JSON of it. So this is basically how you use fetch. You call the fetch request, and then you get the response.json for that to get the data. And it's just returning that data, which is pretty cool. And we already saw, let's actually mint another. So I'm going to use this, and let's go into certify, and let's go into John Smith. Let's just use Smith at yotmail.com, and let's issue this today as well. Now, once we click on this, everything comes back okay. The data is okay, and that data is then used elsewhere. All right, cool stuff. So where exactly are we using our Mint SBT? Let's kind of look at that. So let's go into our Mint SBT API. So if we kind of double click on this, kind of go down, our handle mint function gets the response from the API gateway. And if the response or status is failure, then it will say, oh, we failed to mint our certification. But since we input everything correctly, we got our transaction hash, which we can see from here, which is a response or result.result.tx hash. And we can set the result over here for success. Our certification is BT. This was our success message that we see. And we also set the hash or the transaction hash. And then what we're doing is we are resetting the form so that if we want to mint another certificate, we can do that. Cool. So let's kind of go into how we check to see whether a particular token was minted or not. So if we go into our issue and we go into our verify certificate, right? Ownership check. So there should be a / ownership check folder over here, and we go into that. So this should have our ownership check function. which is basically using the get SBT by owner API that we created. So this just takes an input of a wallet address, and it checks to see whether that particular SBT exists or not, and what are the details for that SBT. So over here we have our owner, we have our ownership, error, loading, just some basic states over here. And once we have our owner, what we do is we go into this handle check functionality, and we set error to blank, set ownership to null, set is loading to true. And this is loading is basically set to true so that we give the API time to come up with a response, right? Smart contracts are usually not that fast. It takes a little bit of time for the blockchain to respond. So that's why we put a loader over here. And similarly, we get SBT by owner, and we got this from our user SBT. So set SBT by owner. This is the function over here. And all we're doing is we're passing in our owner data into this. And once we get a successful response, we set the ownership for the owner, we get the token ID, and we also get the metadata. Pretty cool stuff. Otherwise, what it will do is that it will throw an error saying no certificate was found for this owner. So let's kind of check that route as well. So if we just use a random wallet address over here, we should see that error. It cannot read properties of undefined reading success. So a bit of work to be done over here, but still the same stuff. Yeah, an error occurred while verifying. So if that particular wallet address does have a certificate, it will return the actual certificate. So let's kind of check that again. And yeah, this was my certificate that we printed out. And once it sets that ownership, that's where you want to kind of display the certificate itself. And that's essentially what it's doing. So if it gets the ownership, it shows the certificate for that particular user. It's actually pretty cool. All right. So that is the front end part of our DApp. So all we had to do was we had to take all the elements that we got from the API gateway, from deploying the smart contract, and we put all of that into this template. And if you want to kind of go deeper, you can, the link for this template will be provided in the description. And you can go and check what you can change, what you can improve upon this, and just kind of mess around with the template. And we have a working DApp.
And we also post some really good Medium articles. So check us out on Medium if you're into like a little bit of a beginner, or if you're an expert. We have articles for both of these kind of developers. Thank you for watching, and see you guys next time.